All right, hey AP Chemistry. So another question that people asked for a bit of help on from the chapter 1 exercises was question 137. So it talks about the relationship between kinetic energy using 1 half mv squared and kinetic energy using 3 half pv. So these are equations. We'll talk about kinetic energy equals 1 half mv squared a lot later, and we'll never really talk about kinetic energy being P times V. P is pressure and V times volume. That's a little bit more on the college level. But we want to show the derived SI units, not these numbers, not the 1 half and the 3 half, by the way, that the units of these two are the same. For each of these are those of energy. Okay? Now, energy, side note, the units for energy, and I'm going to put this up here, is the joule, which is a kilogram times meter squared per second squared. Okay? That is found in your text. It's known, but just in case, we want to make sure that the units end up looking like this. So let's see if we could get those derived units for energy, which is kilograms times meters squared per second squared. So I wrote down here that kinetic energy is 1 half mv squared, and or kinetic energy is 3 half pv. All right, so let's do the 1 half mv squared. Ke equals 1 half mv squared. Well, we know for SI units that m mass is the kilogram. Okay, and then we know, or we don't know, that velocity is a speed, and that's distance over time. And we know the SI unit for distance, looking back in our chapter, is the meter, and the unit for time is the second. So our velocity is a meter per second, and that whole thing is being squared. If I do all of this, I'll get Ke is equal to 1 half kilogram times meters squared per second squared. So far, so good. This looks like our joule, which is a kilogram times meters squared per second squared. Okay? The tougher one is this volume one. Ke is equal to 3 half P times V. Now, there are a couple of things. Pressure is a force over area. And force, as you remember, is a kilogram times meter per second squared, which is a Newton. And I also wrote some things down here. Volume could be in meter cubed, and area could be in meters squared. How do I do that? Area is length times width. Volume is length times width times height. And remember, all of these are distances, so meters times meters times meters is meters cubed for volume. Meters times meters is meters squared for area. So let's kind of write that down. We said that pressure is a force over area. I told you that in the problem. And then we know that force, I'm going to use the derived units from a previous video, is kilograms times meters per second squared. Kilograms times meters per second squared. And area is a meter squared. Okay? Now, how do I combine all of these? And think about like when you're doing algebra, right? If I had x cubed over x squared, how do I simplify that? Well, if I have two variables with the same letter and they have different exponents, if I'm dividing them, I end up subtracting their exponents. That's x to the first. If I had x squared over x cubed, that would be x to the minus first, right? If I had x cubed times x squared, I add the exponents. That's x to the fifth. So just like a little bit of an aside. Over here, I have meters on top and meters squared on the bottom. So if I want to combine these two, I could actually say that pressure equals force over area. Meters over meters squared is kind of like if I had meters over meters squared. 1 minus 2, meters to the minus first. Okay? So I'm going to get kilograms times, let's say, meters to the minus first over second squared. Okay? This is the same thing as saying if I wanted kilograms over meters times second squared. Okay? A minus first, and just as a side note, meters to the minus first is the same thing as saying 1 over meter. All right, so I know I'm writing a lot of different notes here, but I'm trying to remind you how we do things with exponents and x's. So if it's at m to the minus first, I can throw it on the bottom. And then s squared was already on the bottom, so I'll keep that on the bottom. Okay? And then this m squared kind of cancels out. All right, so now I have kilograms over meters per second squared. That's my pressure variable. So 3/2 kilograms over meters times seconds squared. Now my volume, I told you that's length times width times height, times width times height. That could be a meter cubed. So now my volume is going to be a meter cubed. And so I have meter cubed on the top here, and I have meter on the bottom. That's kind of like saying if I had x cubed over x, or x to the first, x cubed over x is x squared. Well, I have meter cubed, and I have meter on the bottom. This can become 3/2 kilograms. Meter is going to cancel out, and I'm going to get squared left. So kilogram meter squared per second squared. And guess what? That is also going to match the unit of the joule, which is a kilograms meter squared per second squared. Also, these two sets of units match as well. That means that these two units represent energy. Kilograms times meter squared per second squared. Kilograms times meter squared per second squared. I kind of wrote them a little bit differently, like I put them all under one or the other, but you're able to do that with fractions when you're multiplying. Okay? All right, so that was a quick video on question number 137. Again, this is a bit outside the scope of AP Chemistry, so you're not going to have to derive units. Knowing how to derive units could be helpful, maybe even in physics or maybe in college, but I'm not going to ask you to do a lot of this. It's just good practice to know how to do that for algebra and doing algebraic calculations.